Electric force, first Coulomb's law. As we discussed previously, if there are two charges, if they are like charges, they repel each other. If they are unlike charges, they attract each other. In any way, they are repelling or attracting each other. There is a force. That force is the electric force. Coulomb discovered that force.
Hi everyone. As you know, like charges repel each other and unlike charges attract each other. Here we have a two charge Q1 and Q2. Q1 charge with the 6 Coulomb, Q2 charge with the 6 Coulomb. I can change it like 4 Coulomb or I can increase it. So they are applying the force each other. They are repelling each other actually. That is called Coulomb's law, and they are applying force with the same magnitude amount of force but opposite direction. As you see, this is force of this and this force of this.
If they are not stable, they are gonna start accelerating towards or away to each other, we can say. The closer two charges are, the greater force on them. So that means if the charges are very close to each other, they are applying each other more force. If the charges away to each other, like this, they are applying less force to each other, we can say. And Coulomb discovered that there is a force here. In any way, there is a force. Distance between charges. Distance and the force inversely proportional, because when they moving away to each other, they are applying less force to each other. Like again the magnet. If we have a magnet, north poles are facing each other, let's say. If they are very close to each other, they repel each other strongly. But if they are very away to each other, north and north, maybe we cannot detect any repulsion force between them because they are away to each other, so there will be less force here. Here there will be more force. So if the distance decrease, the amount of the force increase. If the distance increase, the amount of the force decrease. This is similar as the chart.
Hi everyone. In this simulation, we will look at the distance and the force relation between two charges. And the charge 1, this one, charged with the 6 Coulomb, charge 2, charged with the 6 Coulomb. And when they approached each other, and here the written amount of the force, and when they approached each other, as you see, the amount of the force increasing. And then when they move away to each other, the amount of the force decreasing. So the relation between force and distance, they are inversely proportional. The distance between them, if it is decreasing, the amount of the force between them increasing. In this part we will check the relation between force and the charge. Here I can increase the charge of the Q1. Here I can increase the charge of the Q2. So if I increase the first one charge to 10 microcoulomb, as you see, the amount of the applied force between them increase. And if I increase the second object charge, as you see, the amount of the force increase again. So here we can say amount of the charge and the force, they are directly proportional.
And Coulomb stated law that force between these two charges equal Kc, Coulomb constant, that is called Coulomb constant, amount of the first charge times amount of the second charge and the distance between them. And the unit of the charge is the Coulomb, both of them. Unit of the distance must be in meter always, and the force, unit of the force is Newton. there is a problem, sample problem. This problem says the electron and proton of hydrogen atom are separated on an average by distance. So this is the distance between proton and electron. Find the magnitudes of the electric force and gravitational force that each particle exert on each other. Now we are not concerned about this part. We can discuss about it later. But we will discuss about the electric force between these two. As you know, there is a center, there is a proton, neutron. Around the center, there is electron. So the distance between proton and electron, 5.3 times 10 to negative 19. So that is the distance between them. We use F equals K times Q1 times Q2 over R square. K is the Coulomb constant. We will use that constant. K is the 9 times 10 to 9. And the Q1, we can say, which is the electron, charge of electron, that is negative 1.6 times 10 to negative 19 Coulomb. And proton, charge of proton, let's say it is the Q2, positive 1.6 times 10 to negative 19 Coulomb. And the distance between them, which is R, 5.3 times 10 to negative 11 meter. And we will substitute all of them in the formula and we will find the force between them. F equals 9 times 10 to 9 multiplied by 1.6 times 10 to negative 19 times 1.Q1, which is Q2, which is 1.6 times 10 to negative 19 over, which is R, 5.3 times 10 to negative 11 square. That square comes from the formula. And why I didn't use here negative sign, that negative and positive sign gives us direction of the force. It doesn't affect the result of the calculation. So this result gonna be 8.2 times 10 to negative 8 Newton. Resultant force on a charge, they called it superposition. That means in the previous examples we discussed about the force between two charges. If the charges are more than 2, so there will be force more than 1. So if there is a force more than 1, there will be resultant force, because force is a vectorial quantity. So like this in this picture, first object, second charge, and the third charge. They are stationary charge. Let's say if we discuss about the force on the third charge, Q1 apply in this direction because they are like charge, and Q2 apply in the direction of the Q2 because they are unlike charge. So here there will be two force. Let's say this is the F1 and this is the F2. So we have to find the resultant force of these two. We can say it is a superposition or resultant force. Now there is a question. This question is similar as the previous example. And here it says consider 3-point charge at the corners of the triangle as shown in the figures. This figure, Q1 6 times 10 to negative 9 Coulomb, Q2 2 times 10 to negative 9, Q3 5 times 10 to negative 9 Coulomb. Find the magnitude and the direction of the resultant force on Q3. Now this is the first one, let's say. This is the second one. This is the third one. Or we can do it there on it directly. Let's choose another color. Here, this one charged positively, this one charged negatively, and this one charged positively. So Q1 and Q3, Q1 will repel the Q3, and Q2 will attract the Q3. So the forces will be like that. Let's say this is the first force, and let's say this is the second force. First force of the Q1 on the Q3. Second force of the Q2 on the Q1. And the distance here between this, it is 3 meter, between Q2 and Q3 4 meter, between Q1 and Q3 5 meter. So we will calculate them individually, F1 and F2, then we will add them each other to find resultant force. But here this triangle is the special triangle, so you might know this is 3, 4, 5 special triangle. This angle is the 90, this angle is the 53, and this angle is the 37. You should know this to solve this question, or from the tangent you can calculate that angle. So let's calculate the first F1. Which formula we're gonna use here? Again, F equal K times Q1 times Q2 over R square. For the F1, that's equal K times Q1 times Q3 over R squared. And K is 9 times 10 to 9 times Q1 is the 6 times 10 to negative 9 multiplied by the Q3, which is 5 times 10 to negative 9 over the distance between them, 5 meters, so 5 squared. So that result will be 1.08 times 10 to negative 8 Newton. And F2, that is equal K times Q, it is between Q2 and Q3, so Q2 times Q3 over R squared. So again, 9 times 10 to 9 multiplied by Q2 is the 2 times 10 to negative 9 multiplied by Q3 is 5 times 10 to negative 9. The distance between them, which is 4 meters, so it will be 4 squared. So result gonna be between them 5.62 times 10 to negative 9 Newton. And here, if we draw the forces, F1 is this, F2 is this. And if this angle is 37, this angle is 37 too. So here we have an angle which is 37. So we have to calculate the component of the F1 x component, F1x, and the F1 y component. Then we have to add them each other. So F1x is the F1 times cosine 37. So F1 is the 1.08 times 10 to negative 8 times cosine 37. So that is equal 8.63 times 10 to negative 9 Newton. So F1 y, that's equal F1 times sine 37. So that will be 1.08 times 10 to negative 8 times sine 37. So that will be 6.5 times 10 to negative 9 Newton. So F1x 8.63 times 10 to negative 9. F2 is 5.62 times 10 to negative 9. F1x 8.63 times 10 to negative 9. F1y is 6.5 times 10 to negative 9 Newton. So F1x greater than F2. So we will subtract them. When we will subtract them, we will obtain this in this direction, and there will be F1y up direction. So it is 6.5 times 10 to negative 9. And when we subtract these two, there will be 3. When we subtract this and this, there will be 3.01 times 10 to negative 9. So to calculate resultant force here, we have to use Pythagorean theorem. As you know, F net, we can say that's equal square root of the 6.5 times 10 to negative 9 square plus 3.01 times 10 to negative 9 squared under square root. So F net will be, net force will be here 7.16 times 10 to negative 9 Newton. This is the magnitude of the resultant force, and it's asking to us what is the direction also. To calculate direction, I will erase some part. So to calculate direction, as you know, we can calculate it with the tangent theta. Tangent theta, it will be Fy over Fx, and the y component, which is this 6.5 times 10 to negative 9 over x component, which is this 3.01 times 10 to negative 9. So when you do it with the calculator, the angle gonna be 65.2 degree. And also this is the magnitude of the direction. Hi everyone, in this question it says 3 charges lie along x-axis. One positive charge Q1 15 microcoulomb is at the 2 meter. The another positive charge Q2 6 microcoulomb is at the origin. So origin means 0. So Q2 is here. Away to it, which is 2 meter, there is a Q1. Q1 is 15 microcoulomb. Q2 is 6 microcoulomb. And then at what point on x-axis must negative charge Q3 be placed so that the resultant force on it is 0? In which case it's possible. Question says we have to place here, by the way, this is positively charged, this is positively charged, and negatively charged object we have to place here. So how the force on it will be 0. This is the third charge. And Q2 and Q3 will attract this. So there will be force here, second force let's say, third force let's say. And how the force on it can be 0 when the F2 will be equal F3. I mean when they are equal each other, because they are acting in opposite direction. The resultant force of the opposite direction is the subtraction. So when you subtract same number from each other, result will be 0. So that our formula K times Q1 times Q2 over R square. And we know the total distance between them, which is 2 meters. Let's say the distance Q2 and Q3 is the x. So Q2 and Q1 Q3 and Q1 will be 2 minus X, because total amount is the 2. So F2, I said when the F2 equal F3. What is the F2? F2 is the K times Q2 times Q3. Q2 times Q3 over R squared. The distance between them, I said it is X, so it will be X squared, must be equal F3. F3 is K times Q3 times Q1 over the distance between them, which is 2 minus X squared. And the both sides of equation, K and K cancel each other, Q3 and the Q3 cancel each other, so as a result we have Q2 over X squared, which is equal Q1 over 2 minus X squared. And when we do the cross multiplication, Q1 times X squared equal Q2 times 2 minus X squared. And if we substitute the value, Q1 is the 15 microcoulomb. 15 micro means 10 to negative 6 times X squared. Let's make it dot times X squared, which is equal, Q2 is 6 times 10 to negative 6 again, times 2 minus X squared. Let's make this dot, this one dot, that dot a bit large, sorry for that. And both sides of the equation there is a 10 to negative 6, 10 to negative 6. So when we take the root of both sides, we will have the left side 15 multiplied by the X. 15 is under root 6 times 2 minus X. So if we expand the right side, it will be 2 root of 6 minus X root of 6. So when you send this other side, it will be under root 15 times X plus X root of 6. That's equal to root of 6. And here there is a common factor, which is X in parentheses root 6 plus root 15. That's equal to root of 6. So if you divide both sides, same value, so X will be 0.8 meter. Electric field force, the Coulomb, the guy quantified the electric force with the torsion balance. On this picture you are seeing the torsion balance. He quantified with this balance.